Other sampling methods um, can be used. One of them is called the stratified random sample. Um, Simple random samples are always fine, um, but let's take this for instance. Um, let's say you're sampling the opinions of a school about the parking situation, and you do a simple random sample of 20 students. There is a chance, not that it's a large one, but there is a chance that the simple random sample contains nothing but freshmen. To which you say, well, that's a bad idea. They don't have real opinions about parking anyway. A stratified random sample says, well, let's break down our population into subgroups of similar individuals and then do a simple random sample within each subgroup. Okay. A subgroup is called a strata. Oh, sorry. The subgroups are called strata. And we do a sample random sample for each stratum and then combine them all into one big sample. Um, let's take a look at this with this example having to do with uh, sampling a sunflower field. A British farmer grows sunflowers for making sunflower oil. Her field is ranged in a grid pattern with 10 rows and 10 columns shown in the figure. Irrigation ditches, that's these blue areas, irrigation ditches run along the top and the bottom of the field as shown. The farmer would like to estimate the number of healthy plants in the field so she can project how much money she'll make from selling them. It would take too much time to count all the plants in 100 squares. It's too much time to do a census. So she'll accept an estimate based on only 10 out of the 100 squares. So use the table of random digits or technology to take a simple random sample of the 100 grid, to make a sample of 10 grid squares. Okay, record their locations. Now, this sample has like B6. I'm going to change this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what I'm going to do is I'm going to generate two random numbers. And those two random numbers is first going to be a row number, so a column number, and then I'm going to do a row number. And I'm going to do that. Um, I'm going to do that using um, Desmos. So I'm going to get Desmos. I'm going to make it a little smaller to get it out of the way. So over here, right? And I'll have my little thing over here. And then I'm going to use random, but I don't want random from 1 to 28. I want random from 1 to 10. And I don't want two numbers. I want, or four numbers. I want two numbers. All right. And so we could say that um, one of the randomly chosen cells is 3 comma 10. And let me write 3 comma 10, and I'm going to mark that over 3 down 10. So that particular plot is in our sample. Now, if I hit this little thing that looks like shuffle from your phone, I can then get another sample, and that's 8 comma 6. Sorry, 9 comma 6. 9 comma 6 right there. Let me do another one. 8 comma 10. And it's this one. Do another one. 2 comma 2 right there. 6 comma 8. And this is again a simple random sample. We've got 5 so far. Let's do 5 more. 3, 6. 1, 8. 1, 10. Oops, 10. 1, 2, 3, 4, 5, 6. We need two more. 10, 6. And 4, 6. 4 over 4 down 6. Right there. Okay, so there's 10. Now, that's a simple random sample. Every combination of 10 plots are all equally likely to be chosen. But what if we did stratified random samples, but we're this time going to stratify using rows as our strata? Meaning, I've got this first row, and I'm only going to choose one from that particular row. Now I don't need to generate a pair of numbers. To I only need to generate one number. So from the first row, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm in position 4. So I'm in 4, comma 1. The next one would be something comma 2, and it's 5, comma 2. Next one's going to be something comma 3, and it's 6, comma 3. The next one after that is going to be something comma 4, and it's 4, comma 4, right there. And then 10, comma 5, and then 3, comma 6, and 1, comma 7, and 8, comma 8, and whoops, something comma 9, 10, comma 9, and then our last one is 10, comma 10, right? So this is stratified only one item per row, right? Now, why would we do that? Well, we think that maybe the sunflowers that are closer to the irrigation ditch, maybe they have a different kind of thing going on. Maybe they get bigger because they get more water, or maybe they're smaller because they're flooded. We don't know, but we think there's commonality, perhaps north and south here. All right. Now we could also take columns of strata, and again, generating 10 samples there, but these will start 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. And let me go ahead and start generating random numbers there. 1, comma 2, 1, comma 5, or 2, comma 5, 3, comma 8, 4, comma 5, 2, and 4, and that's a 5. So 4, comma 5. Okay. This is 5, comma 7. 6, comma 4. 7, comma 6. 8, comma 5. 9, comma 8. There. And then our last one, 10, comma 5. There we go. And so that's stratified by row, only one row in, only one cell in each, okay. Stratified by column, only one cell in each column got chosen. Now, we did a lot of work there to get those three different kinds of samples. Here's what we're up to, though. Here's the actual yields. Let's pretend that we actually did do a census, and here's the actual yields. Um, in this cell, there was 106 plants, but in this cell, only 99. Perhaps we see that closer to the water, the yields look a little higher than the ones that are in the middle. Okay, let's see how this plays out. We're going to go and we're going to go back to our sample. Now um, I've got the yields on a sheet that you can't see, but I could go ahead and say, okay, in the cell 310, that was a yield of 109. Okay, in the yield 96, that was a yield of 107. And 810 was 107. And 22, 102. And 68, 68, 102, 36, 98, 18, 104, 110, 107, 106, 98, and 46 is 98. Let's find the average of those numbers. I'm going to go back to I'm going to go back to Desmos. I'm going to go to the next line, or sorry, I'm going to stay in this line. Let's create a table. And in this table, I'm going to put those numbers in. So 109, 107, 107, 102, 98, 104, 107, 98, and 98. I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. I'm going to go down to the next line. I'm going to type, I want the mean of that variable x1. And we find that this mean, what was it again? 103.2, x bar, 103.2. And that's again the mean using simple random sampling. Let's do this again for stratified random sampling where we stratified by rows. Again, going back to my grid, saying what each of these are. 105, 52 is 103, 63 is 100, 4, 4, 99, 10, 5 is 98, 3, 6, 98, 1, 7, 103, 8, 8, 104, 10, 9, 106, and 10, 10, 107. Again, let me switch over to Desmos. Let me put in another table, and I'm going to go ahead and put those numbers in. Oh, how do I do this? So I can see both at the same time. There we go. 105, 103, 100, 99, 98, 98, 103, 104, 106, and 107. Right. And again, got down to the next line. This is the mean of x2, 102.3. X bar, 102.3. Okay, we're going to do this one more time. This time, again, this is stratified by columns. Stratified by columns. 1, 2 is 103. 2, 5 is 100. 3, 8, 103. 4, 5 is 100. 5, 7, 101. 6, 4, 99, 7, 6, 99, 8, 5, 98, 9, 8 is 102, and 10, 5 is 98. Back here, let's add another table, and let's get those numbers in. 103, 100, 103, 100, 101, 99, 99, 98, 102, and 98. Go down the next line and ask for the average of those X3s, 100.3. Okay, so each of these has an average. They're all random samples, so they're all thought to be representative samples. But are there any advantages of doing all that random sampling? And the answer is there is. But you can only see what the advantage is by looking at many, many random samples and the averages that each of the random samples um, produces. So I've got a little thing to help us along with that. I've got the spreadsheet that I developed, and I have it so that we have all of those yields, and the green boxes are part of a random sample. And every time I hit Control Alt Shift 1, you'll see it get a new random sample, and you can see over here that it's producing an average. And then what happens is it doesn't do it as nicely as I'd want, but every time I do that, it actually pushes that random sample number down onto that list. So if I hit this again, you're going to see a new random sample, and you'll see that the new number at the top of the list has changed. Every time I hit Alt Control Shift 1, the new random sample average shows up. And what we can do with that is that I can take all of these random samples that we're taking from the simple random samples, and I have a lot of them. I can take them and I can put them into Desmos. Now to put them into Desmos, I'm going to say this is from the simple random sample. So I'm going to say capital S equals, then I'll hit paste, and it says, look at there, you got a list with 112 of those random samples. And I can make a dot plot out of them. Dot plot of S. And there's all those random samples. Right? Now, does the dot plot look different if we stratified by row? Well, here's my stratified by row. You'll notice that there's only one green box per row. It's calculating the sample mean here, and I've got a list of a whole bunch of other sample means. Again, Control Alt Shift 1 does another random sample. Again, only one green box per row. There's another random sample. And now I've got this list. How many are in this? A whole lot of them. Copy. Let's go back to Desmos. And I'm going to go, and this is by row. So I'm going to call this R, paste that in, hit enter, and I want a dot plot of R. Now, I don't know if you can tell, but the dots for blue seem to be a lot more compact than the dots for black. Perhaps it'd be easier, instead of looking at dot plots, I said, let's look at the box plots for these. Box plot for simple random sample. Okay. And let's also look simultaneously at the box plot for stratified by rows. And I can offset this by, I don't know, I think by 3. Look at the difference in there. There's a lot less variation in the one that's stratified by rows than there is the one that's simple random sample. Both of them have about the same center. So both of them are giving us a reasonable guess, but there's less variation in the guesses made by the stratified by rows. guess I really do want three. All right. And then we got to do it one more time. So maybe stratified random really makes a difference. Columns, again, whole lot of sample means based on stratified by columns. Copy those, go back to Desmos. This is by columns. Enter, and let's look at the box plot for that group. Again, I think I'll offset 5. So we can look at all 5, all of them. So when we stratified by something that was important, we got less variation. Remember, we conjectured that the growing near the water sources are going to be different than the ones away from it. When we stratified on something that wasn't important, it ended up didn't matter, did it? Simple random sample and stratified by column are about the same, but stratified by something important like rows did make a difference. So what do we say in relationship to all of this exploration? And that is this. Okay. Stratifying by rows produced estimates with smaller variation. Because the water did have an effect on the growing. Stratifying by column was no worse than simple random sample. Okay. Okay, last piece of this. What is the mean number of plants in this in the population? And how well did we do? Well, I go back up to here. I've got it hidden away here. The population mean was 102.47. So if you did all 100 plots, found their average 102.547. Now, how did that compare to the means that we got from the 3 samples? Well, the mean from the simple random sample was really close. The mean from the stratified by rows was really close. And the mean when we stratified by columns was really close. So all of them gave us means that were good estimate of the population mean, but the mean from the stratified by row gave us the best choices. All right, let's finish up this lecture. Okay. Last kind of sampling method is called a cluster sample. To take a cluster sample, first divide the population into smaller groups. Ideally, these clusters should mirror the characteristics of the population. Then choose a simple random sample of clusters. All the individuals in a chosen cluster will be included in the sample. Okay, so we're going to take a look at sampling 3 ways for a high school. We've got 800 students in the school, and there are 200 in each grade. Uh, how could we sample? How could we sample this the school? Well, if we do a simple random sample and we use like a number generator, we could just generate numbers from 1 or 001 to 800. And then we want the first, or we're going to choose the first 80 non-repeated students. Okay. And again, what's the side here? Well, it's relatively easy to do. By the way, we could also just put all well, 800 students' names into a hat, need a really big hat, and then mix it well and choose the first 80. But if we did a stratified random sample and take a look, all the ninth graders sit in the back, rows 601 to 800. All the 12th graders sit in front. For a stratified random sample, we could say, let's generate numbers from 001 to 200 and choose the first 20 non-repeated, right? Because we're going to choose 20 seniors, and then we'll do the same except for juniors, and we'll do the same except for sophomores, and then we'll do the same except for freshmen. Okay, and that will give us a stratified representation of that school. Now, what does a cluster sample look like this? Well, in cluster, and I want you to think about the word cluster as being relatively close together. Well, if I count it up, there's these groups of 10 seats, and there are 80 groups of 10 seats. Okay, so here's group one, here's group two, here's group three, here's group four, all the way to group 80 is that last row, 79 is the previous row. Okay, and what we could do is generate, and we need 80, and there's that. So I could numbers, generate numbers from 01 to 80, and choose the first 10 or 8 non-repeating groups, and then interview everyone in each group. And that will get us 80, and they're all closer together. And that makes it easier to talk to them because they're all close together. All right, that concludes our 411 lecture.